Afternoon, evening and morning everyone. I hope you can hear me clearly. Yes, my name's Jeff Stapleton. Today I'm going to be talking on the Quality Renewable Energy training guideline that we developed within the IEA PVPS Task 9. I have been involved with the promotion of renewable energy from an industry's perspective since the early 90s, even though I have been running my own companies during that period of time. And on the screen right now is the jigsaw puzzle we believe which a quality industry requires. The two aspects we're going to talk about this afternoon are on opposite ends of that jigsaw: quality training programs and technician certification schemes. All those other things shown though are all critical to that, particularly guidelines, installation standards and guidelines and product standards typically link into how quality training programs need to be taught and how technician certification schemes and the technicians who follow that will then apply that training and ensuring the system's going correctly. One of the things I've been promoting for many, many years is that for this industry to become mainstream, training must become mainstream. It has been many ad hoc training programs conducted over 30 plus years, and when we're talking training, we're talking technician level training, not university degrees, masters. They've been well catered for in many countries for a long time. These are the hands-on people, out technicians who are actually doing the installation. If you look at other trades, in many countries, it is mainstream. If I wanted to start a company in a number of countries around the world, I could go find electricians, I could go find plumbers, but would I find solar technicians who have been to a qualified course before I sort of hired them? And that is what this document and what I've been involved with for many years is all about. And you can see I made that statement at a conference 14 years ago. It was probably one of the first times I started promoting the words of the mainstream of this industry. Background and how, so in Australia, I've been involved promoting training since the early 90s, and in the mid-90s, or about 96, I met the person on the screen there, Mark Fitzgerald. He started in 1995 a body called Institute for Sustainable Power. He recognised the need for quality training as well, and the need that that training had to be accredited against some framework. So that was the body he started. I met him in 97. We kept in contact regularly over the next couple of years, to the point where he invited me to be a board member since 2000, and with him early in those early 2000s, and even since then, we've been trying to promote accreditation of training in Asia. We did some projects, Pacific Islands, some African countries. But unfortunately, Mark passed away in the mid-2000s. However, his work continued. That the quality framework he put together that ISP was promoting is what IRAC, for those who might know, in the US, now runs that framework and is how they then accredit training programs within the US. So the guideline, which was sort of finalised April this year and probably so dated then, but officially sort of launched about July. I've been often approached over the last number of years with the growth of the industry saying, Jeff, we're going to get quality training programs in our country or in this region. And so since I kept on been asking that question, I thought it was important to actually put it all down in a simple document. Deliberately tried to make it short because people don't read large documents, but the document does then promote where you can get the further information. So I've kept it as a small report, so hopefully it will get read by more people. Why is it needed? Unfortunately in this industry, I can still commonly keep on finding photos of poor quality systems. from simple things where I've gone to do inspections and like this. The person was on fire at the time when they put it on to make sure the clamp was on. He was in a hurry, but it means it was also not found during commissioning or testing. Here, the cables are exposed to the sun. All standards IEC, and that always talk about making sure the cables are out of the sun. Those are the black cables there. Even though they're technically UV stabilised, they will still deteriorate. You can see how that back leg is not straight, and that switch on the right hand side is facing up, so moisture would get into it when people open it up. This is part of an 8 megawatt system. I won't name the country to be fair, but yep, you can see the wiring. This is the wiring from the arrays. Any animal or anything will damage that cable. Here we even have another system in another country where it was the cracked box, which would then lead to moisture getting in. Moisture getting into the DC can lead to shorts, can lead to fires. Attempting to do some mechanical protection, but only partly doing it. You can see where the conduit's damaged. So water will get into that, but it's also the fact things would get in there and damage the cable. Here was a battery situation where the company didn't follow what the manufacturer said in the size of the cable that had to be ran. Only ran 25 mil from the battery to the inverter, where it had to be 50. They melted a cable, and then they realised they had to double the cables up, but they literally only had 25 mil cable lugs, so they actually then put 2 cables into the 1 lug. Obviously, they probably did not have enough lugs on the site, because this was a remote site, but they never sort of went back to rectify the scenario. And here is, yes, they've run the earth wire, but if you look closely, they have not even stripped back the wire, so there'd be definitely no earth connection. So it's unfortunately, I could show many, many of these type of photos collected over the years and still collecting, as little as last week. So this is what quality training is all about, is to prevent this. It can damage this industry greatly if we don't overcome people making these type of mistakes. And even here, that cable should be mechanically protected, somehow going through the roof. Somebody steps there, that cable's going to be damaged. And where this is so critical, this is the solar cable going from the array down to the inverter. It is unelectrically protected because it cannot be protected. So if that gets short, you've got nothing but a fire when it's 500 volts DC. Again, more loose cables. So it's generally in the cabling area where we do see a lot of errors, where people just do not take that extra caution to make things safe. But I've seen where erosion has happened from their frames and they've collapsed. Foundations have been undermined, but it's more in the poor cabling. So, the guideline. This is the contents. We talk about the components of the quality training framework. All these I'll talk a little bit more in detail on other slides. But many people who are pushing for quality training don't really understand what that means. But to be fair, many people in many industries just know they send their people away to get trained from technical colleges. They don't necessarily understand all the language that goes with that, all the mechanisms. The average person just wants to know that if they're sending somebody off from their business to be trained, that they're coming back with the right skills. So that's where it gets difficult, because it's like any industry. Training is an industry, has its own languages, has its own unique aspects to it. So sometimes people struggle to understand if they attend the meetings, like some of the meetings we have on units of competence and job task analysis. As mentioned, we then do talk about technician certification and accreditation programs, because we think that is what's also required, that after a person gets trained, they then get certified. In some countries they are looking at licensing. So with that, you maintain those licenses. In many countries it's done by either continuing education, having to collect points, or in some cases they've been doing case studies to prove you're still doing the work correctly. We then look at what to do if you wanted to introduce a quality training into a country or region, and then what can be done if the framework isn't in that country. The appendices have a lot of examples of existing frameworks, units of competence, task analysis. I'll explain them more in a minute, and some of the countries that have already got national training frameworks relevant to renewable energy. When a framework is being run, there must be an administering body. Like I said, with the IRAC in the US, generally in most countries it is a government department, part of the Ministry of Education or similar. Sometimes it's a vocational training ministry. So their job is to develop the standards which all training centres must meet. Talk about that in another slide in a minute. The references on the side are those to the document, establishing the qualification levels across the framework. Now, this technician level is generally known as Certificate 1, 2, 3 or 4 in many frameworks. A qualification level often has 10 or 11 stages, with the top stage being PhDs, doctors, philosophy. So it's aimed at the certification level. After certification level, in many countries you'll have diploma, advanced diploma, and then you get into degrees, bachelor, masters. As I say, the technician level is generally down in those 4 specific areas, and maybe in sometimes diploma for some people when they advance. This administering body must then establish the mechanisms for developing the course structure for the different qualifications across a multitude of different industries. So it's not just having a framework for one particular, it's a framework for all vocational education and university level education in some cases. Then the framework only works when training centres then have to apply to be accredited and to get audited. So those procedures must be put into place. So for instance, our company is what's known as Registered Training Organisation in Australia. We took us 6 to 12 months to go through that process originally. We still get audited every couple of years to ensure that we're meeting all the standards. And that's the final part there, that mechanism of the auditing of the training centres. 2 main components within a framework, when I keep mentioning the word standards, is quality management standard, which is like any management standard can be applied to any industry, like ISO 9000 series, but I'll talk more about that. And then the second, so that would then be general for any training centre, whether that training centre is running plumbing courses, electrical courses, renewable energy courses. What then makes the training centre then unique under the framework is the competency standards they will teach you to. So again, I'll explain them in a minute, but you'll see 3 names there: competency standards, units of competence, job task analysis. Generally the same thing, just different parts of the world, just name them differently. Like many aspects around the world, things just have that slightly different name to them. So the management standards, it's independent of what the training centre is actually offering. It's just how the training centre must have a quality scheme. latest procedures relating to process and student applications, minimum qualifications for the teaching staff, policies related to health and safety, conducted assessments. There always must be complaints, procedure if somebody feels when they fail and they think they should have passed. So there's a whole lot of long list if you actually look at a quality management standard, which are referred to in the appendices of the document. Units of competence, job task analysis. In summary, they basically describe the essential knowledge and skills that somebody needs to do a skill, be that to install a grid connected PV system, install an off-grid PV system. That is sort of be the title of the unit, and then that unit would describe all the knowledge and skills that that person needs to do that job, and then it's the role of the Quality Training Centre to actually then make sure all that is being taught and assessed. They'll also talk about what prerequisites might need, required. Sometimes this is like mathematics from school, what level, and those type of components. Technician training is generally nowadays what they call competency-based, that you are competent to do the job. Again, this is a large system in one of the regions around the world. The inverters are on the other side of that. It's an 8 megawatt system, and that is the AC cables coming out of the inverters. So I report on this system the other year. I think you could imagine it was pretty scathing of the quality of the wiring. That is not what you'd call a competent technician who did that work. Since there's a variety of ways units of competence could be portrayed, generally they're very similar in nature, but just talking the Australian ones, as you'll gather, it's where I come from and are very familiar because I've been involved with these for many years. Yeah, they'll describe what the unit is, how it's applied, is there any licensing requirements for that country, what are the prerequisites. It talks about the elements performance criteria. I'll go through that in a little more detail. What are the required skills and knowledge? I'll go through that a bit more detail, and then the evidence guide. The following slides, which explain some of those last three items, I've deliberately grabbed installing LV grid connected PV system to help with the explanation. In a number of jurisdictions around the world that I've come across, when they are doing competency-based, they break the elements of the down into three areas: preparing to do the work, doing the work, and doing the reporting of the work, no matter what that work might be. In this case, it's installing photovoltaic power systems. It could have been prepare to install a diesel generator, or could have been preparing to wire a house. Then the next is installing it, and then generally the completion. Performance criteria, so your sort of three elements, so under each one of them, they would all then have performance criteria. So for the second one, which is to install, there are 9 performance criteria. So this is what then must be part of the assessment, that you have met this performance criteria. So I just showed a couple of examples. 2.4 was system components installed to comply with technical standards. Wiring is terminated at components and associated equipment is 2.5. So all those poor quality work would be not meeting 2.4, not meeting the technical standards. The IEC 62548 standard says that all cable must be mechanically supported. If it's in the sun, it must be in conduit. So it's just actually making sure people are addressing those type of standards when they're being taught. Then generally in the assessment guides nowadays, you then have all the required skills and knowledge, and these can be then numerous. Not all of these might be assessed completely individually, but assignments, assessments must be written to ensure that you are able to assess most of these. If you had to do every single one, it can be very difficult to tick every single box, so you're trying to make them where one assessment will cover a lot of things. So again, in this particular unit for installation of PV system, grid-connected PV, what we call T1 is PV installation requirements, and then they then list all those things: OH&S, common types of roof, fixing methods, array mounting methods, etc. Now, I'm not going to list everything again. All these types of documents are referenced in the guide and how you can get copies of these type of documents. But you'll see it's called T1 because in this one there's actually 9 different areas of required skills and knowledge. So you can see T1 we had a bit more detail. Here's T2, the electrical. So when it says requirements in carbon passing, in the document there'd be another 6 or 7 items under T2, similar under T3 and third, so it breaks it all the way down, all the different components of the system, and making sure all the knowledge that's needed to be known there. Evidence guide, that's instructions to the trainers who are doing assessment. Not all countries, assessments done by the trainer, sometimes can be done by an independent third body, and that independent third body still needs to be given. So there's uniformity that they're told exactly what type of evidence they need to collect. So, do the overview, do the critical aspects, contact specific resources for assessment. For instance, in Australia, the training centre must have 2 types of roofs that the people are trained in assembling, tiled and metal. So a minimum of 2 roofs, they must be assessed against each one. And the method of assessment could be everything from oral assessment, observation while they're actually doing the installation work, to examination. And then there's sometimes concurrent assessments, and sometimes with other units at the same time. So if you're doing a complete certificate course, certificate 3 in Australia, for instance, is 900 hours over a 3-year period. So there's a lot of times where people are doing parallel units and they'll have concurrent assessment across those units. Sorry, it's a repeat of the original. So when it comes to, I mentioned technician certification schemes, so we talk about that in the document as well, because we believe they're very much required to raise the professionalism of the industry. In the document, we do a little bit of detail on 2 schemes because they are the 2 most longest running schemes that have been operated. The Australian scheme is 25 years ago when we started putting it together, and it was done. Literally, there's a number of people in the industry were tired of the amount of poor systems being installed, but in those days, particularly systems not going in to meet the customer's needs, being oversold. That a 500 watt solar system could do a lot more than what it actually would do, and people did not want to buy solar because they just didn't trust it. So we started our scheme to overcome that. So within that scheme, it's gone through many phases. We have installers and designers that must be accredited. They now must go through continuing education, so they haven't got it for life. The NABCEP scheme got started in 2003 in the US. Probably 2 things that are different about the 2 schemes. The Australian one now is fairly compulsory. No government subsidy in Australia will fund any solar if it hasn't been designed and installed by an accredited person. The North American one is voluntary, but it does have a lot of people who are voluntarily joined up to that NABCEP scheme. The next aspect of the document is, right, it's all good talking about what a training quality framework is, but what if you do want to introduce it into your country? or you want to have quality renewable energy training in your country. So the document goes through the simple steps that should be followed, and the one mistake I keep seeing people do is thinking that they've got to start from scratch, thinking that there's nothing there already. So like anything, the most important thing to do is do the research and find out what's actually happening, often called a needs and gaps analysis. What is the market? Is it about to be a boom in solar rooftop market? Say like a country like Sri Lanka is about to go through? Is it still just an off-grid market it's a small industry still? So that's the first point. Then you need to have a look, how many people do you actually need trained per year? Is there, so therefore that then leads how many training centres you'll need. Are there any training programs that have been currently being done in the country or have been done in the past? So is there any resources there already? And then that's when you have a look to see if is there an existing quality training framework. So our push is, if there is an existing framework for a country where it's already there for other trades, the best thing is then to get renewable energy just into that framework. Don't sit outside that framework. Based on the results of that needs and gaps analysis, you then start to look at how to get the renewables into, if there is a framework there. Obviously, the first step is often doing the unit's competence, forming the committees who would then develop those. But again, don't reinvent the wheel. There are many around the world that are publicly available that can be used as a starter. And then therefore, it's developing that by having the committees. Where training should be conducted, very importantly, not suddenly doing so many training centres that you flood the market and there's not enough business for those people who get trained. And then if you find in a few years' time, then all the training centres close up stop doing it because it wasn't. So you're trying to get a sustainability of both the training and the ongoing technicians. What will be the format of the training? Is there material that's readily available? Is it going to be common material developed for the whole country? And then it comes down to how the trainer's going to be trained and their skills. In our country, you're not supposed to be a trainer unless you've actually worked in the field for 2 years. That was the old way. It's not always enforced nowadays in all the trades, but 20 years ago it was. You had to have 2 years with work experience before you could be an effective trainer. The big question still is, ISP 20 years ago was trying to have the program that went international. So when a training courses in a country that didn't have a framework, it could get accredited, even if there was a framework in days, to maybe get a renewables in for just one off-grid training centre located in the country might not have been practical back in the late 90s, early 2000s. So that's why ISP got created, but it was very hard in that market to try to make that sustainable. We've only a few training centres around the world, particularly in the early 2000s. So this raises the question, if this is going to be needed for countries, is anybody going to take this role on? Now, I'm here in Madrid because I sit on the IEC Technical Standards Committees. This is something we're looking at within the IEC. They're wondering whether they could maybe play a role in looking at accrediting of training. The World Solar Council is talking the same thing. So places like ARENA and that are also trying to address these type of issues. So maybe in the next year or two, in the next couple of years, a body might get formed that can take on the role of what ISP used to try to do. Examples of existing training is what's also covered in the document. Yes, there is a focus on a bit on the US and Australia because they've been around the longest. However, we look at other ones that are happening because right now West Africa, ECRI, ECOWAS, They've actually now developed a unit of competence on small solar for the 15 West African countries. They are about to now go through the process of developing a technician certification program based around that unit of competence, working with training centres that can teach that unit of competence. And then they're going to have a look at, is there a need for a regional accreditation of those training programs? So sometimes it's a bit of a chicken and egg. What do you start with? Training, and then you form the certification, or do you get a certification scheme up and running and then start to form the training? Kenya, they've been looking at licensing and doing common curriculums. Malaysia has one for Grid Connected for many years. South Africa is looking at it right now. Singapore has had Grid Connected within their training framework for probably about 10 years now. United Kingdom has put it into theirs. In the Pacific, where I also work, we've had an EU project where for 15 countries there, we now have certificate 1 through to 4. They're not as detailed as much as I would like to see at this point in time, but it's a start. And now it's working on how to get training centres up and running in those 15 island countries. So slowly starting to happen. Yeah, a lot more than what was around 5 to 10 years ago. So then in the back, we actually have, in the appendix, we have a bit more detail on the layout of the Australian framework so people can see it, and also on the Interstate Renewable Energy Council, just to see how different things are. Probably one big difference I should probably emphasise between job task analysis and that unit of competence I described before. A lot of times the job task analysis just deal with those essential knowledge and skills, because they, like for instance, under the IRIX NABCEP scheme, people go get trained, but then NABCEP conducts the assessment. It's not the training centre. They can conduct assessment, but to get NABCEP, still the other way. So I was told to make sure we had plenty of time for questions, so I aimed it at 35 minutes, which we've now reached that time. So thank you for all your attention. I hope there hasn't been too much background noise.